Today, we continue our topic about techniques for design dynamic test cases. I remind you that on previous lessons, we discussed about type of techniques or type of methods for creating dynamic test cases. There are two big categories of uh, methods: techniques for developing static tests and techniques for developing dynamic tests. And in previous lesson and today we are speaking about techniques for developing dynamic tests. Uh, if we use this type of techniques, we can use techniques based on structure or based on specification. And on uh, previous lessons, we talked about methods based on the structure, and you can find the video record of this lesson in the leader. And today we will speak about methods based on the specification. We will start from highlights, main and the most important details. After that, we will consider some methods of this approach for creating tests. And after that, try to test some function as example of usage in this approach. If we speak about methods that are based on the specification, we speak about data-driven testing. In this case of testing, we have not access to the source code of our application. We have only complete and accurate specification. I remind that specification is a description of our program or part of program. In this description, we write about functions of our program and input and output data and their types. And if we have not source code or access to the source code, the complete and accurate situation is the most important element for creating test cases. When we talk about test cases, we understand that test cases or tests is a set of input data and the set of output data. And there are two sets, and these sets are the minimum information that must be specified. We can add to this information some details about steps of perform code or screenshot from testing process or another information. And for this type of methods, we need to create a good test or a good test cases. A good test is a test that has a high probability of detecting errors. And if we have as input data some number and two different solutions of dependent on the value of this number, we need consider only two tests. For example, if we have number, for example, 18 and if our value was 18, there is solution 1. In another cases, solution 2. In this example, a good test is a test where input data number are is less than 18. For example, first test number 16. The second test may be number 19 or 20. And this test are good because they have a high probability of detecting errors. And if after this test are used the third test with a number equal 15, it is bad test because this test is very similar to this. This variant good, good, not good, because probability is low in this case. And we need to prepare some test with high probability of detection errors. Like here, method. And let's go to some methods based on specification. And when we speak about methods for testing application based on specification, there is a black box method or black box approach for testing. Black box methods includes these methods for testing. There are equivalent partition, analysis of boundary condition. From time to time, you can find similar title of these methods, analysis of boundary values. It is equal method for equal to it. The next assumption of error, functional diagrams, and state transition. And when you will do your laboratory work number 3, you can use one of these methods for prepare test cases for your function. Because it is not hard task to this method and this method there are easy method for using and for understanding. Let's consider the details of this method. And the first method in our presentation is equivalent partition. In this method, when we have a lot of variant of input values for our data, and we can't carry out testing with all values of this data, we need to separate all values and create some classes. These classes are called correct and incorrect classes. And if we have a big amount of input data, yeah, it is all input data. Into data set. If we speak about correct and incorrect classes, these classes are subset of input data set. For example, correct and incorrect. And after that, we can use only one value from this part and one value from this part for testing our software, our application or function. When we separate input data set on two or more classes, we can use some rules for separating data. And these rules you can see here. And the first is if the value of parameters is set by range, it is appropriate to consider three classes. One with the limits, two from the right and left outside the limits. For example, we know that student can receive some marks for subject. And we have 5 for excellent, 4 good, 3 and less than 3. It is in cases when subject is not pass. If we have this boundary or this limits, we can use one value from this range. It is first a class 1 from this range, the second class 1 from this, third and from this. Yes, we talk a lot of integer value from negative infinity to positive infinity, yes. And we need only marks from maybe from 0 to 5. And if we create test where marks equals 0, after that equals 1, equals 2, equals 3, 4, and 5, in this case, we have a lot of testing. But if we use this method for partition of input value, we can use only for test from this for correct values or for correct classes and two additional classes for incorrect 5 and 6. In this method, we covers all integer values by 4 correct classes and 2 incorrect classes. It is more easy than test our application with all values from infinity to positive infinity. The second case in equivalent partitioning methods, there are is the specification describe a set of input values, and there are reasons to believe that each value is treated separately. Then a class should be allocated for each value, and one class is incorrect, which is not part of the set. And maybe a good example for these cases, there are um, cases from rules of drive the car. And if we have some values of traffic lights, there are red, white, yellow, white, and green light. It's an example for these cases in equivalent partitioning method. I have specification for describing a set of input values, and there are a reason to believe that each value is treated separately. When I have green light, I can go. In this case, I must stop, and when I have red light, I must wait the changes of the light. And I need red test for red, yellow, and green light, and another test for not green, not yellow, and not red light for another color. And if I have this four tests, I can say that I fully cover all my application by test. In the last cases, is if the condition must be is given, then two classes should be considered on which satisfy the condition the other does not. For example, if I have a logic value or Boolean value true or false, it is a good example for this case. If I have some value that equals true, I need to create two tests where this values is value equals true, and the second when these values not equals true and equals false, and it is that it is all needed tests in this case. Let's consider the principle of using classes when we need to present of results of testing software or part of software by this method. We can use two type of tables, and there are, you can see these tables. The first of them tables for formation classes, and the second for describing the test cases or simple title testing for this table. The first table I need to describe all incoming conditions. And in the first column, I write description of the essence of the parameter. For example, n number of students, or c a count of devices, or another, or m a matrix of integer value, for example. And in the second and third columns, I need to write a description of the correct and incorrect classes. When I am writing about correct classes, I write some statements about the set of values that correspond to the specification. And in the second case, when we write about incorrect classes, we write information about the sets of values that don't correspond to the specification. After that, I prepare some values or some set of values for coverage these classes. For demonstrate the result of covered some function by this method, I use this table in column that is called covered class. I write the number class. In the second column, I write some identifiers of test or test cases. For example, the first, second, third, etc. After that, I describe input data value and output data value that I expect in this test. Let's consider the example of an equivalent partition. I have a specification of the function. You can see this specification in my screen in blue rectangle. I have a function that function finds the first maximum element in an array of integers. This function has two input parameters. There are an array of integers and the number of elements in the array. It is integer value 2. And as a result of performing this function returns integer value. There is number equal -1 if the array is empty, or 0 or value that is greater than 0 if I find the position of the first maximum element. I cannot source code this function because now I use methods from black box approach. In this approach, I have not access to source code. I use only specification. And in this specification, I can see two input parameters in my function. And these parameters are incoming conditions And you can see in this row, I write about an array of integers. And in the next row, I write about number of elements in the array. And after that, I propose some variants of value of four elements of this array. And the first array is empty. Okay, it is first class for my function. Next, array has all different elements. Okay, there is the second class, and the third array has two or more elements that equal maximum elements. These classes are correct because all these values we write according to the specification, and there are not values that don't include of this set. We have not any additional restriction for this value. For this reason, incorrect classes is empty set. After I consider the number of elements in the arrays, and I can say that the number of elements can be value equal 0, and the second case, the number of elements is greater than 0. There are two classes. There are correct classes, and they have number 4 and 5. And the last class is incorrect class. It is case when the number of elements is less than 0. After that, I need to write test. For example, for this, I can write test case 1. Array is empty. Number of elements size is 0. It is input, and this value is output. And I can use this test class for cover class number 1 and class number 4. After that, I need to create the next test cases because I have some classes without coverage. The second test case array equal 1, 2, 3, and size is 3. And output value will be the position of the first maximum element. In my cases, output is 2, because we start calculate of position from 0. 0, 1, 2. When I use this test case, I have coverage for classes number 2 and number 5. After that, I need the next test cases for classes number 3 and class number 6. After that, we have all needed test cases and can start in the test of our function for finding the first element. Maybe you have some question about these methods.
No.
Okay. I clear my drawing and we are going to the next method. There is analysis of boundary conditions. In this method, data are sampled at the boundaries of the input region, as many failures are due to defects in the processing of the boundary values of the input parameters. It should be supplemented with values on both sides of the borders. And now we can return to previous example with marks of our student. If we have 5, it is excellent, good. Um, Satisfactory, um, and no satisfactory from 0 to 3. And in this case, uh, I have um, some restriction for input data. Input is mark, and mark we need from 0 to 5. In this case, I need to create test case where mark is equal 0 and to test uh, where mark is greater than 0 and less than 0. For example, 1 and -3. After that, I go to next restriction or next boundary. Uh, there is 3. I need to create a test where mark is 2 and one values in left side and one values from right. That from left I can use 1 and in right side I can use 4. 4 is boundary 2. I need test for this value. 1 from left side and 1 from second side. And there are 3 and 5. And for 5, I need to prepare test where mark is 5, less than 5, for example 4, and uh, greater than 5, for example 7. And so I need 1, 2, 3, 4, 5, 6, 7 test cases for testing my function. but I don't need to test where mark is 8, 10, 100, or another value, or very small values such as -10 or 100 with sign of minus. I need only these 7 values for a full coverage of my function. But if I read the specification, and in this specification is not any values with type integer, float, long, or a number or another number, I can use this method for testing. These methods only for values with type such as integer, float, double, long, long, double, or similar type. I can use this method for string, char, or my special types such as classes or structures. And as example, I proposed the next specification for function. The function determines the interest rate of the deposit depending upon the term of the deposit. For 2 years is 10% from 2 to 5 years inclusive, 20% our 5 years, 30%. For 10 of less than 2 years, we have 0%. The deposit term is an integer. And for this specification and for this function that is described by this specification, I create some test. The first test, input data 2. It is the number of years, and output data is 10. There is rate of the deposit. The second 5 and 20, because here I have full boundary. Two years and 5 years. Our first boundary and the second boundary. After that, 5 and 2. I need to create a test for additional values from left and right side. From left, there is 1. From right, there is 3. For number 5, the left is 3, 2, and the right, I propose 6 as input data. And this number of the test is enough for full coverage of our function. If we use methods of boundary conditions. The next methods is methods of assumption of error or predication of errors. When we are testing by these methods, the process is largely intuitive and requires consideration of specific cases. The main idea of this method is we need to make a list of possible errors or situations in which they appear and then write test for them. I propose to consider two easy specifications. The first is this. I have the function of sorting the array by rows using the bubble method. And I think there are a possible situation in which errors appear. The first array is empty. Uh, we know that in bubble sort method, some elements change their position, but I don't know uh, how it will be made if there are no elements. For this reason, the array is empty in this list of situations. The second, an array has only one element. An array has element of equal values. I include this situation on my list because if you remember, in bubble sort method, we have condition. If array I is greater than I plus 1. And I think that we can have some error in this condition. For this reason, I check this situation, and for this, I add this situation to list of situation on which errors appear. And the last, the array is already sorted and ascending order. In this case, the condition of if statements are false every time. And I think it is maybe a problem for our function. And I need to check this variant, and for this reason, I write this situation in this list. There are fourth situation in which some errors appear. And after that, I need to create test for first assumption. I need test where array empty. In second, where array has only one element, has element of equal value, for example, you can see there are number 2, of number 3, and the last and that there are all situations in which we can find some errors. And I must run my program with this input data. The second specification for function that perform a binary array search. I remember that in this search, in these methods of search, we have array with some elements. We choose middle element, and if our momentum is greater than that middle element, we go to right side. In another cases, we go to left side. After that, we separate left or right side on two parts and continue our search. And I think there are some situation in which mistake appear. The further array is empty. In this case, I can't find middle element. For this reason, the situation in my list. The second, an array has only one element. This case is similar to previous. Third, the number of elements is even and not even. It is interesting variant because I need to divide all elements on two parts, and the result of division there is 1 or 0, and for this different case I need to check how my function will perform this division. And the last, the searched value is not found in the array. And for this function that there are all needed situation for consideration and future testing. Do you have any question about this method?
It's clear, ma'am.
Okay. Let's go to the next method. Maybe the more hard to understanding about this method is the better variant for function that has a very hard input conditional that include 2, 3 or more parts. This matters we use for individual function. If we have model that includes some function, we need to separate this model on some independent function, and after that start this method. In first step, we identify each individual function. After that, for this function, we need to identify all reasons that affect its outcome and all corresponding reaction or consequence. When we speak about reasons, we need to know that reasons are separate input condition or an equivalent class of input condition. After that, if or when we have a list of reasons or list of consequences, we can build a graph or diagram, and in this diagram we connect the combinations of reasons with the expected reaction to them. The diagram may be accompanied by nodes or restriction and combination of input condition. After that, for each consequence indicated on the graph, determine the test that by going through of the combination of causes that generate this consequence. For construct this type of diagram, people use some basic designation, and this designation, so you can see on my screen, there are identity, negation, and or. And when we have a simple connection between reason and the result of working our function, we use only a solid line, and if we have combination of the reason, we use negation or a sign or conjunction for and conjunction for or. For designate some relationship between reason, we can use additional designation. There are E, I, O, R, and M. Maybe the most wise situation where we have a mutual exclusion of reasons. For these cases, we use E, and if we have a situation when at least one of the reasons is present, we use I, or for one and only one of combined reasons is possible, R if one reason requires the presence of another, and M for concealment if the house takes the value of 1, then the combined consequent is 0. And now I propose to consider some example for better understanding of this method. As example, I have a function of adding an item to a list. I remind there are a lot of data structure, and list is one of widespread data structure for saving element one for one in RAM. And if I need to present this as a structure, I can use this picture. First element, this element has link or reference on next element, this on next, and etc. It is first element, and this link code next. The first element in this type of data structure is the smallest element. And if I have sequence of number 1, 3, 5, 0, in this list there are 0, 1, 3, 5. And if I need to add new element, I need to do this operation according this rule. And I will have two independent reason. The first, this is empty and this is not empty. If I have leaves that is empty, I have the result of performing my program, such as adding to the beginning of the list. If I have not empty list and a new element is smaller than all the elements, I have this result too. But if I have not empty list and new element is larger than all elements, I will have the second result of performing this function. For example, in this list, if I add a new value, for example, 8, I need to add this element to the end here. And the last combination list is not empty and the new elements is smaller than some elements. As a result of this combination, I will have situation where we have adding to the middle of the list. For example, if I have a new element equal 4, his position is here. 4, 5. And this link will be deleted. After that, I have a list of causes or reason, and I have a list of result or consequence. I can construct the diagram. I will do drawing. Let's switch the next slide. Here you can see the diagram for the function to add an item to a list. Reason 1, 2, 3, 4, 5. It is a reason from previous slide. And C1, C2, C3, there are consequences from this slide too. And in this diagram or this graph, I present the combination of this reason. For example, reason 2 and reason 3. This sign has meaning and reason 2 and reason 4. And reason 2 and reason 5 and reason 1 is independent reason. If I have this reason, I will have this result. And you can see the additional designation for reason. There are some exceptions for reason 1 and reason 2. Look here. Reason 1, reason 2. List is empty. List isn't empty. One list can't be empty and not empty. For this reason, we have exception situation. Reason 3, 4, and 5. New element is smaller, is larger, is smaller than some elements. There isn't a value that is smaller and is larger. For this reason, we have the second exception of reason. And this sign demonstrate this relation between reason 3, 4, and 5. So that when we have a reason, when we have a list of sequences and we have a graph or functional diagram, functional diagram is a title of this graph. We can start to create the test. In this table, we look only some descriptions. Yes, I can see that for theme 1, I need reason 2 and reason 3. But in this table, I can't see the type of relationship between 2 and 3 reasons. And if I have graph, I can see reason 2, reason 3, connection between this reason and relationship and after that I write some test. For first case in my table, it is note 1, test 1. When we have input first is null pointer, elements, new elements is 1, and list is empty. I have output, first points to the first element equal to 1, and content of this list, there is only one number, 1. For the second case, test 2, input there are first points to the first elements equal to 1, elements not is 0, and list 1. As outcomes of this test, I will have a list with 2 numbers, 0 and 1. Note 3 or case 3, when we have a list with 0 and 1 and have new element is greater than all elements. As a result, we have list 0, 1, 8, and the last test when we have list with 0, 1, and 8, and we need to add elements is equal 3. After performing this function, we have result 0, 1, 3, 8, and you can see 3 in middle position in my list. It is true result or right result, and it is good. And I have only for test. For a big function, this function has 5 reasons. This function has 3 variants of results, but for all these reasons and consequence for all their combination, I need only for test. And for check that it is right decision, I need this method. I prove that 4 is enough number of tests by this method, because in this method I need 1 test for 1 combination of causes, and that's all in this method of testing. And the last method are with state diagrams. From time to time, this method calls transition by state. In this method, to distinguish the states of the system, to determine the condition and sequence of transition between them. Match the input data so that transition work, and that's all instruction for this method. For example, I have a state diagram for bank system. It is state diagram for ATM, and if I need to get some cash, some money, yeah, I need to submit a card. After that, I enter a PIN code. The system check my data. If the data is correct, I can choose the operation. But if data is incorrect, I repeat the enter of PIN. After that, we have repeating for checking, and okay, the data is correct, and another the data is not correct. After the third check, if we have incorrect data, the card will be blocked. But if we have the correct data, we can choose the operation get money or check the state of our account or another action. And if we have this state, we need to prepare one test for one different combination of combination of one different transition by state. In this case, where we have a correct PIN in first entering and incorrect, correct, incorrect, correct, incorrect. For the system, we need 1, 2, 3, 4, 5 success. And this state diagram is the instruction for separation of test cases. And that's all about a method for creating dynamic test cases. And we can speak for resume of our topic. And in this part of our action, we can say that there are some different approach to testing. And if we use of dynamic test, in this case, we use some sets of input data and output data for execution of the program. Test can be designed based on structure, specification, and experience. And on previous lesson, we spoke about structure-based method, and today we speak about specification-based method. When designing on the basis of the structure, white box methods are used. It is a logic-driven method, and in this case, we have access to source code. But when designing based on the specification, black box methods are used. And in this case, we have only specification, only description of our function, methods, models, application, etc. And we have not any string of source code. And if you have a project which we need to test, the best option would be a combination of several techniques, some method from white box and one or two methods from black box. That's all about software testing. Do you have any questions to me?
No, ma.
Okay. Thank you for your attention. On this point, we end the topic of testing for software, and on next lesson on benzene, we will speak about risk control. And risk control will be the last topic in our subject.
Okay.
Thank you. Good. If you have any question, we end our lesson. I wish you a nice day. Goodbye.
Okay, goodbye.